Okay, so if you have two functions that are being multiplied together, like f of x and g of x, and you want to find the derivative of that, you can use the product rule.
Okay, so the product rule proof starts, first you have to understand the definition of a derivative. So the definition of derivative is d over dx of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So that's just the definition of the derivative. So for the product rule, what you're going to be trying to find is the derivative of two functions multiplied by each other. So f of x multiplied by g of x. And we can plug that into the derivative formula first. So the limit of h minus 0 is going to be equal to f of x plus h times g of x plus h, and that's just the same thing up here. Then it's going to be minus f of x times g of x, times g of x all over h. So that's just plugging this into the definition of a derivative. And then in order to be able to manipulate it to make the proof work, you have to plug some other stuff in. So in order to manipulate it, we're going to plug in f of x plus h, or we're going to subtract f of x plus h times g of x, and then when you subtract something from an equation, you have to add it again, so we're just going to add the same thing, f of x plus h times g of x. And then we can start to manipulate it and split it up. So the limit of x minus, or the limit of h, as h approaches 0, we can split this into two parts. So we can split it right here, yeah. And then we can split it right here, and then we can rewrite those. And we can factor common factors out, because f of x plus h and f of x plus h, those have a common factor. So we can factor f of x plus h out, and then you're left with g of x plus h times g of x, or no, minus g of x, because you have the negative, it has to be distributed, minus g of x over h, and then you can add the other one, which g of x can be factored out of both of them. So take g of x to the outside, then you're left with f of x plus h minus f of x all over h. Okay. Then you can find the limit, you can plug it into the limit for each piece. So you can start to split them up. So the limit as h approaches 0 of f of x plus h, this is going to be equal to this up here, times the limit as h approaches 0 of g of x plus h minus g of x all over h, and then you're going to add that to the limit as h approaches 0 of g of x, and then you're going to multiply that by the limit as h approaches 0 of f of x plus h minus f of x over h. So you split those all up, and then this just comes out to be equal to f of x, and then this is the same thing as up here, which is just going to be equal to g prime of x, because that's just the definition of a derivative, and those are multiplied together. And then you carry the addition sign down. This one is just equal to g of x, and then that's just the definition of derivative again. So it's times f prime of x, and that's the product rule. D over dx times f of x gx is equal to f of x times g prime of x plus g of x times f prime of x. And that's the proof.
Okay, so then if we want to find the derivative of g of x, it's a similar thing. So the derivative of the first one, which is just 1, times the derivative of, times this part left alone, plus the first part left alone times the derivative of the second part, which is 4x. And then multiply that out. And we get that, and then combine them. And then the answer is 6x squared plus 4x plus 3 for the derivative of g of x. Okay, so if I wanted to use the product rule to find the derivative of this function that has two pieces multiplied together, I would take the derivative of, so take this piece and then take the derivative of this, which is 4, plus the derivative of the first piece, which is 3 minus 4x, times this piece left alone. And then multiply that out. 12x minus 8x squared plus 15 plus 12x minus 20x minus 16x squared. And then combine those. Minus 20x minus 16x squared. And then if you combine all of those, you get negative 24x squared plus 4x plus 15. So that's the derivative of f of x.